my dears. How are you? I'm very fine. I'm called Asraki Halu from Ethiopia. I'm doing here at Abbas University as physics lecturer. Dears, I'm requested to solve this problem. And then I've seen thoroughly. And then I understand something. It is very important for you too. So can we do together, please? Great. What the problem says first? It says how far would a stone of a density 2.5 grams per cubic centimeter, starting from rest, sink in the water in 2 seconds. Great. Now dears, to do this problem, we have to remember two important things simultaneously, or respectively. One, we have to remember what Newton's second law status. Two, we have to know in depth about Archimedes' principle. What Newton's second law says, the net force which acting upon the object is simply the product of mass and an acceleration. That's good. What the Archimedes principle states, if an object is completely or partially submerged within a fluid, the object may experience an upward force that is known as force of buoyancy. And then force of buoyancy should be equivalent with the weight of the displaced fluid. Don't forget, my dears. If so, just consider this is it to be a part of a fluid or parts of a liquid. And then, after a time while, let it be the position of the stone here. And then the stone is completely submerged within the water. From this we understand something. What that? The volume of the displaced fluid and then the volume of the stone is equal. And then there is a downward force known as weight, which is simply mg. And then there is an upward force, which is known as force of buoyancy. Nothing else. There is downward mg, and then upward force is force of buoyancy. And hence, from the Newton's second law, the net force which acting upon the stone is force of buoyancy, and then the difference between force of buoyancy and then W, so-called weight. So, my dears, MA, where M is the mass of the stone times acceleration, and then the force of buoyancy as what we have discussed earlier in your regular class, that is simply the weight of the displaced fluid, that is the density of the displaced fluid, the volume of the displaced fluid times G minus, this is simply mg, where m is the weight of the stone, and hence the density of this stone, the volume of the stone times g. Don't forget, this is the mass of the stone. Great. But the mass of the stone means, as what we did here, the density of the stone, the volume of the stone times acceleration. which is equal to the density of the displaced fluid, volume of the displaced fluid, times G minus density of the stone, volume of the stone times G. And then we said something. Since the stone submerged completely, the volume of the stone and then the volume of the displaced water are equal. And hence, density of the stone times A times the volume of the stone is equal to the density of the displaced fluid times G minus the density of the stone times G. Take us one. Simply volume of stone. Why? Because the volume of the stone and then the volume of the displaced fluid are equal. And then just cancel from both sides. What remains? Look, my dears, simply an acceleration is equal to the density of the displaced fluid minus the density of the stone, and then times G, the whole over the density of the stone. Great. The density of the displaced fluid, since it is water, 1 gram per cubic centimeter. The density of the stone is given, that is 2.5 gram per cubic centimeter. And then times 10 meter per square of second, the whole over 2.5 gram per cubic centimeter. It's 1 gram per cubic centimeter minus 2.5 gram per cubic centimeter, which becomes negative 1.5 gram per cubic centimeter. And then times 10 meter per square of second. And then the whole over 2.5 gram per cubic centimeter. Now, gram per cubic centimeter cancel. What remains here is negative 1.5 times 10 meter per square of second over 2.5 at the end. The acceleration becomes negative 1.5 times 10 over 2.5 and then meter per square of second. By 1.5 divided to 2.5, it becomes 0.6 times 10. It becomes negative 6 meter per square of second. This negative sign indicates or tells or illustrates to us where is the direction of the stone. The direction of the stone is downward, and then it tells to us that anyhow the acceleration becomes simply 6 meter per square of second. Thank you for watching. Please don't forget, put your comment up on the box and then subscribe to my channel. Bye-bye.